Hello, this is the course instructor, Professor Jinguk Lee. Let me get started today's flip learning video using the title here, Spaces and AI. As you know, AI is one of the buzzwords nowadays. Probably you are kind of freshman, so to you, AI is not that kind of buzzword or something new terminology in your dictionary. Is probably very common. But someone like me, some kind of old man, to me, AI is totally new term in our domain. Formerly, of course, we watched the movie about AI. At the time, we thought it's really something future thing, not related to my today, my present time. So that means your parents ages and someone like me, that's AI is something very future technology or something not grabbable. Okay, so that's the sort of the feeling what we felt against the term AI. But my point actually is it's not that kind of far future thing. My point today is it's sort of nowadays hot topic and issue even in our domain. What is our domain? AEC FM, architecture, engineering, construction, and FM. That's our domain, AEC FM. In other words that I preferred word, that's a design domain, right? So in our domain, so-called design domain, how AI could be affected and what's going to be happened in our area. That's actually the question I like to raise up today. So let's take a look. That's the reason why I didn't put design and AI or AI design something. Instead, I put this term, spaces and AI. So far, we have walked through understanding spaces and creating spaces. So in the perspective of creating space and also another time frame based perspective, what I mean is present and future perspectives, what's the kind of preview about when we are saying the terms spaces and AI. Okay, let's take a look. Today, I like to show you using this flip learning video something space and AI, space related technologies, but we have walked through some technologies in the future, but this tech actually simply means very cutting edge and buzzword terminology in technologies. What is that? Representatively, it's going to be ICBM, AI, IoT, cloud computing, big data, mobile technologies, and AI. But the topic today is AI. So let's take a look a little bit more about AI and some related technologies. Take a look. For introducing you what's the AI, I like to show you this one first. Sorry for Korean, all this in Korean because my research originally written in Korean, but I think that's good, right? You can read and you can take a look and my additional description. The first industrial revolution is something about machinery, right? So at the time, we stick to the physical world. So how to efficiently, productively manufacture some cotton-based fabrics or some other things we need in real life. So that's the main essential of the first industrial revolution. How about the next one? It's also about some conveyor belt and some automation in factory, productions, manufacturing, and so on. The third industrial revolution actually is critical. That's something about cyberspace. You know, one of the big guy in industry and academia named William Mitchell. William Mitchell was the writer of City of Bits. City of Bits. You know what's bits? Bits is the sort of atomic unit to count digital files. So 8-bit going to be 1 byte, and 1 byte is sort of atomic minimal unit for representing character. For example, this kind of alphabet A could be recorded in 1 byte, something like that. Okay, Korean character, of course, some 2 byte or some other different type of units are there. But anyway, my point is, according to the series of bits, there are sort of totally new and ground-shaking concepts are introduced. Representatively, cyberspace. I'm not sure you students think about what is the cyberspace or how to feel when you heard cyberspace or something. But someone like me, to me, that was the term cyberspace was really revolutionary at that time. At that time, we felt only physical spaces, but we, in our imagination, in our brain, of course, we can think any kind of cyber things, but there is no way to represent there is something virtual, something cyber things. But thanks to computing and thanks to internet, thanks to World Wide Web, in your daily life, World Wide Web is including Facebook, Instagram, or something else. You are living inside of the World Wide Web, but at the time, World Wide Web firstly introduced, and at the time I designed and built our department website or my own personal website using HTML languages or something. Anyway, my point is, at the time, the concept of cyberspace is really revolutionary. But the problem was too much cyber, too much virtual. So sometimes we are missing, and sometimes we are forgetting I'm in real world. Okay, that was sort of side effect and something bad things from that the so-called third industrial revolution. But think about this one. What's the main objective and main topic of Industry 4 or Industrial Revolution 4? Simply, this is the integration of cyber and physics. That is why, in other terms, we call it cyber physics. Okay. So first, second, they all about physical spaces and physics, and third one about cyber things. But the fourth one is totally about their integration between cyber physics. Okay, that's the point. That is why when we are saying Industrial Revolution 4, we always say something about our real world and something cutting edge technologies in digital, especially using digital things. Think about that. IoT. What is the IoT? Internet of Things. Before Industrial Revolution 4, we always say only internet. We don't care things or something physical actually existing objects in our real world. That was the problem. So we realized that, okay, cyberspace, internet, World Wide Web, digital things, they are all good. But the problem is they supposed to be exist on top of our real world, real life, real daily life. So that kind of recognition, that kind of thoughts created this one, cyber physics. Okay, so that is why we can say Industrial Revolution 4 has real meaning and its own value inside of it. Okay, so what kind of technologies? I told you IoT, cloud computing, big data, and mobile technologies with artificial intelligence, AI. So industrial revolution 4, fourth industrial revolution, or simply industry 4, industry 4.0 simply means the connection between real world and virtual world. Okay, so that's why we use also similar terms, online to offline, O2O, or cyber physics, and so on. So how to integrate them using human beings? Actually, it's not using, okay, it's a weird term, based upon humanism, based upon human beings, something like that. Okay, that's the point. Anyway, for data collection, we need IoT. IoT simply means the embedded sensors. Where are sensors in our daily life? In our door, in the wall, in our wall mount, in my smartphone, in my computer, even in front of my laptop screen there is camera and microphone, and in my smartphone there is gyro sensor and GPS and so on. There are many sensing devices. They are all invisible. They are all embedded into some type of our real world objects. Okay, so what they do, they collect data. Okay, so data could be through the cloud computing, amount of stacked data. They are so-called big data. Okay, so how to analyze those big data? The analysis technology going to be using this one, AI. Okay, and some more technologies such as blockchain or some other things, but they are all related to so-called ICBM AI. Okay, so let's take a look. In our domain, there is some related technologies. For example, first one, digital twin. It's, as it literally means, twin means something totally same, semantically same, right? I told you there is a computational building model you designed and real world building. Actually, in design stage, there is no such actual building, but what if your design realized in couple of years after your design, and then those two designs going to be totally same? So we can say they are twin, but this is not real thing. This is digital file. So this is digital file. So we can say this is so-called digital twin of existing building. Okay, that is why I brought this idea, this one, for you. Think about that. In other words, when you are designing something, in a certain perspective, we can say, okay, your design file could be one of your digital twins, but that real world object still doesn't exist in real world. But probably someday in near future, it could be realized. So we can say your digital model, your digital design file, it could be one of the digital twins. Okay, but semantically, what's the good digital twin? Amount of information you embed inside of your digital model. What if you only draw floor section elevation, just drawings, symbolized, very plain, simple drawings? Can you say they are your digital twin? I don't think so, because if you draw something, drawings, of course this one represents your real world model, but really tiny subset of information, the information set you can build. What if you design your own computational model which has amount of real data, real information? In that level, we could say, okay, that could be digital twin. Okay. Next thing I like to bring your attention is this one, XR, so-called XR. You know VR, virtual reality, and AR, augmented reality, and mixed reality. as you see, VR means virtual reality, AR is augmented reality. On top of VR or on top of real vision, you can add some additional screen or additional objects. So this is so-called mixed. There is no specific definition between VR, AR, MR. It's not that easy. That is why nowadays we are saying XR. This X could be anything. The same way I told you, you are studying design for X. You are building computational model for X. Design for X. Your major for X. Space related X. That could be your future thing, your future job or future work. I told you before. So this X could be anyone, anything, okay? Anything. That's my point. So this is something about interface. This one is so-called something about some physical virtual things of your concept totally based upon real world. This one is something about user interface. What's user interface? Your keyboard, your mouse, they are all user interface, especially graphical user interface. How about your smartphone? You use Siri or Samsung's voice recognition assistant, I forgot the name. Anyway, that kind of voice recognition use voice interface. How about your screen, smartphone screen? Touchable, right? You can touch icon, you can drag, you can zoom in, zoom out by using your fingers. They are all user interface. But specifically we say that's touch interface or tangible interface. Tangible, right? Tangible. The term tangible means touchable, okay? Touchable. Anyway, this is XR interface. XR interface has very immersive and realistic. That is why we are saying this one is realistic media or immersive media. Simply, we can say realistic media. Think about your radio or your television. On top of your television screen, you watch movie. But sometimes you can feel it is realistic, but TV screen's monster never come out from your TV screen, right? It's flat 2D based screen of movie. What if you are wearing goggle, VR or AR goggle, and then at least, even though real monster not gonna be running outside of the screen, but you can feel something very, very realistic. That is why this kind of media interface, we are saying this is realistic media. I know there are some VR bang, AR bang. That's weird. Say something like this. Anyway, something like 노래방, there is VR bang in Sinchon. You know that, right? And then you can feel some very realistic media interface paying some money. That's our nowadays very common thing. Anyway, this is our major and our domain related technology. That's why I brought this one. Let's move to the AI things. Take a look. Probably you know this book, Finding Wall-E. Where is Wall-E? Take a look. This simple animation shows you how deep learning can learn how to detect Wall-E's face using this camera. By using camera, okay, find out in 5 seconds. This machine has a camera here. This is camera, okay? And this robot arm can point out where is that Wall-E face among hundreds of these face pictures. Mechanism is simple. The camera in charge of detect entire faces here, and the computer here, actually the computer probably Arduino based controller, this one. Computer detects and classify and find out just one single Wall-E's face based upon its machine learning technology. And this moving, controlling this robot arm and point out simply where's Wally's face. That's it. Mechanism is not that complicated. But the important thing is deep learning enabled this one. Okay. Moving, controlling this robot arm, that's not that complicated. The problem is how to find Wally's face and where to move that robot arm. Okay. Deep learning has the role to find out Wally's face. That's my point. You know, AlphaGo, it's already very long time ago event in our memory, right? AlphaGo, the Go is in English, it's Baduk, right? Baduk. Go game is in Korean, it's Baduk. And what's the alpha? You know, you may know the alpha version software, beta version software. If you like games, you heard that. Okay, this game just released in beta version. So alpha, beta, this kind of abbreviation, this kind of prefix means sort of preliminary software application. This is the first version of software. What kind of software? Playing Go game, right? So now you understand what's the meaning of AlphaGo. This is human-made AI software to do Go game, but the version is alpha. So that's the kind of trademark of the software name. And then in that perspective, we can put this one, Alpha X. For example, Alpha Design, Alpha Interior Design, Alpha Tennis, Alpha Law. How about law? I'm not sure. How about Alpha Architecture? Something like that. These are some our domain issues, and this is the prefix of this software name, alpha version. If there is alpha interior design, does it could design something much better than real interior designers? According to the lessons learned from AlphaGo, you know, the world champion defeated by AlphaGo. Only one game, except only one game. Isador won only one single game at the time. Anyway, the point is, how about alpha design, alpha architecture, alpha interior design, alpha something X? Exactly you want to do. Can you defeat alpha X? Actually, this is kind of stupid question because my intention today actually is bringing your attention about AI and its effect to our domain or some out of boundary of our major domain, whatever it is. I like to bring your attention to think about a little bit more about this issue. That's my point actually. So let's take a look this one. Actually today's material mostly in Korean, I'm sorry, but the point is here. Around 20 years ago, when we got in some recess, economical recess, because of IMF, at that time, Korea government president met Bill Gates and Son Jung-il, and they suggested what to do in that kind of economical crisis period. First, high-speed internet. Second, high-speed internet. Third, high-speed internet. That's exactly what they said to the Korea president at that time. Why I brought this one to you? In this government, President Moon also met the same guy, same person, Son Jung-il, And he said, what should I do? When he asked from Korea president, he said, first AI, second AI, the third one AI. I'm not talking about this is exactly right, because this is his kind of vision, his insightful suggestion to do. I don't judge that is correct or wrong, okay? My message from this one is 20 years ago, we anyhow, we did this, okay? That is why our high-speed broadband has kind of world-class hardware equipped, and as you know, when you are growing up, when you are in elementary school, when you are in middle school, high school, at least the hardware performance and infrastructure was world top class, okay? Anyhow, so in this government, they also got similar recommendation about this. So my point is, I don't want to judge this is right or wrong. My point is, AI is in that level of, it has importance, okay? Very critical factor. Anyhow, AI has amount of more meaning, reflecting this kind of historic story or something, whatever it is, okay? That's my point. Let's quickly take a look the possibility of using AI in our domain, our design domain, okay? Let's take a look. You know what is armchair and chair? Take a look. This is, in this chair, if this is a chair, there is no arm, right? But take a look, this chair. This one has arm like this. So we can sit down here like this, and we can lean over that arm, our arm, right? So this is armchair, and this is just chair, okay, without arm. Take a look. So more than several hundreds of images in my computer, in my lab's computer, we trained the AI machine, precisely say deep learning. Deep learning machine trained what are armchair and what are just chair without arms, okay? So if I show this exact chair without arm, and then this one responses, okay, this is just chair without arm. Very easy case, okay? If I showed something like this chair, and then my deep learning model answers, okay, this one armchair. Very easy cases. But take a look this case. What do you think? Is this an armchair or just chair without arm? It's not that easy. How could we describe this is, what is this? Is this an arm or just extended back? This is back, right? It's not that easy. Think about it. What is your answer when I ask you, is this an armchair or just a chair without arm? In my experience, when I ask this one to students, to my audience in the lecture, or to my audience in some other type of guest lecturer or whatever in the lecture room, the audience is 10, 20, even 500. Result was always same. Around 75% of people answered this is armchair. But around 25% of people said this is just a chair without arm. But my point is not here. My point is, in my same deep learning model, when I finishing the training, I mean this training, after this training, that deep learning model answered, okay, this one has 74% chances of armchair and 26% chances for a chair without arm. My point is here, how they are close like this way. This is real human answer. This is computer's answer. How they could be similar like this level? At the time, I was really surprised. Another thing I found at the time is, okay, AI, deep learning, whatever it is, it has enough meaning to use our domain. Because, think about that. Why this one answered like this one? This is so-called stochastic approach and stochastic answer. In Korean, this is this one. Not deterministic. Deterministic means whatever the question was, answer always should be yes or no, or true or false, or 0 or 1. That's it. That is so-called deterministic. But in AI world, answers always stochastic. So this means this reflected in real world by real people in this way. Surprisingly, they are almost the same. That's what I found at the time. Amazing, isn't it? That's my point, okay? A little bit more complicated case. Let's take a look. You know, Eastern interior design style. You know, Western interior design styles. This number of pictures I collected from Korean, Japanese, Chinese cultural heritage website online. Those pictures, they are very professionals, right? Those professionals provided those professional interior design images. And take a look. RIBA is Royal Institute of British Architects, which means very professional about Western design style. Okay, they provided those Western design interior images via this website. So I collected those images and trained my deep learning model. And then take a look. How about this? Even if you are just beginners, even if you students are just freshmen, I believe you know what kind of this design style is. Of course, think about it. Some line based and some stroke lines on the windows and some pillows, something like that, and some wood structure, the color, images, something similar to some kind of Japanese style or Zen style, simple style. That's correct. These are Eastern design style. So this is the answer from my deep learning model. 99%, 98%. How about those two images? I showed you Eastern design style, so probably they are Western design style. That's correct. 87% Western design, 85% chance of Western design, because they are actually from some European interior image website, something like that. So, what do you think? This answer from deep learning model, amazingly precise to detect design style. You know what? When I was undergraduate student, I had to memorize those series of pictures. Rococo style, Baroque style, Romanesque style, Modernism style, blah blah. And I took the exam. When I on the front slide, on the front, there is a picture in 5 seconds, and then I write down in 5 seconds. So total 10 seconds for one question. At the time, I took that kind of exams in the midterm exam. I don't want to blame that kind of old-fashioned exam is not good. At the time, and even nowadays, I think that is one of effective way of examination. I don't blame it. I think it's okay. But my point is, how about you are taking examination with this my deep learning model? Can you win against this machine? Probably it's not possible, because this machine really fast and precise. At least about this design style, Western, Eastern style, or armchair style, whatever. Okay, and I trained some more things. For example, last time I told you 84 square meters Korean apartment style. Very typical design was there. 3-bay, 4-bay apartment. How about this one? Bathroom of that apartment, bedroom, entrance area, kitchen area, living room area. I collected total 10,000 each, so total 5,000 images from website like this, and I trained my deep learning machine. And then my deep learning machine now knows what is this picture means. At least that's one of the pictures from Korean apartment. Okay, so take a look. As you see, these are very typical Korean apartments, kitchen, entrance, bedroom, living room images. And then take a look. If I feed this image, and then this machine answers, okay, this is 99%. Okay, not this picture actually, this is wrong about this one. This is bathroom, okay, bathroom, and its percentage, sometimes, here it is, 99% bathroom, okay, this against this picture. Only 0.1 possibility chance going to be an entrance. That means this is almost 100% bathroom. And actually it's true, right? This is bathroom picture of very typical Korean apartment. Anyway, this kind of precision we found from this training model. So we have more training. Classic style, modern style, natural style, elegant style, casual style, and so on. All these are very qualitative terms against design style. But take a look. How designers can determine this is casual 100%. There is nothing about natural, nothing about modern. That's wrong, right? My point is, even to real professionals in interior design, there is no 100% or no 0%. But there is some prioritized, some major design style or something like that. When we say, okay, this looks modern, there is always something other aspects of design. Because that is design. That's the nature of the character of design. Okay, that's my point. In that sense, in that perspective, now we can find out, okay, deep learning, AI, whatever it is, it has its own function, its own potential to apply our domain. That is my point, okay? So this is the result chart I can show you. From this picture, my deep learning training model answered like this way. How about this one? When I feed this image, natural 67%, casual 30%. Take a look. Whatever you feel like, anyway, based upon this training model, this deep learning answered like this way, not deterministic. There is no determines 100% determines in this kind of design domain. That's my point. That is why this train model also answered like this way. Modern 87%, natural 13%. That's kind of so-called realistic and very natural answers we can get from this deep learning machine. Okay. Some more questions are here. So some more applications. So far, I showed you some design style or some holistic images from given images, but we can dig more inside of that. We can break down some more detailed features, such as object detection. Think about that. This interior picture, probably it looks like a modern living room. What if AI can detect the objects? For example, okay, this one is a sofa, couch. Its design style is modern, simple style. Functional feature, it has armrest. Of course, this one has armrest. And it could be realizing its material. It's not leather, it's fabric. And seat capacity, it's seat for two, something like that. Also, there is a tea table, there is plant, there is some lighting bulbs and door, some bigger plant, floor rug, and so on. This kind of object detection also trainable. What I mentioned, train here means training. Okay, so trainable means machines can learn, okay, using some appropriate data feed. So as a result, my actual deep learning machine in my lab, my personal computer now learned how to detect those furniture or interior facilities, components, objects, what we showed this one to the computers, and this one detects. And also after detection, this one can judge its functional feature, material, capacity, and even design style. As you see, this is very classic style of chair. This is Scandinavian style. This is very simple modern design, and so on. Based upon this kind of feature detection, design style detection, we could generate this kind of computer software. This computer software is looking like very simple software, but anyway, the function of this software is to detect design style and design function. How many people can sit on top of this furniture and how many sittings in that picture, in that room, something like that. And this one can detect material. This one even can detect other type of information about design. Before this kind of application, who did that? Of course, someone like you. I mean, some professional designers, okay? What's the difference between ordinary people and designers? Designers can explain about that design, that real picture, that image. When someone showed her sort of reference design image, and then designer can say, okay, this picture, you like modern style, but you like this kind of some classics as well, you like it. I'm gonna reflect that taste into your design plan. And you love this style, you need something like this functions, you need this kind of fabric material, and you don't like probably this one, blah blah blah. That's going to be the communication between client and designers. But what if we have this kind of application, so-called AI application, equipped with deep learning technologies? Is this a threat to designers? Actually, that's the one of the similar question against this film learning video today, but actually I don't think so. It's not a threat. If this could be a threat, and then in our industry, entire domain, no one can be existing as a professionals because of this AI. Anyway, my point, rest of story, we can talk about in the class. Okay. My one thing that I can wrap up in this lecture slide is no worries. Okay. We can maximize, we can take maximum advantages from this kind of cutting edge technology like AI, deep learning, and so on. Okay, that's my point. See you in the class. Thank you.